In this video, we're going to take up one more problem on projections of points. The problem reads as a point capital P is 45 mm above HP and 60 mm behind VP and 30 mm from right profile plane. Draw the three principal views of the point and also state the quadrant in which it lies. So the problem is how to identify the quadrant. The condition we have to observe here is the point is above HP and behind VP. So above HP and behind VP, since the condition is given as above HP and behind VP, obviously the point should be in the second quadrant. If you see the problem here, when you see the step 1, you can see the point is above HP, that is this distance is above HP, and also behind VP. The vertical plane is here, the point is from here, the distance is behind VP. When you look from the top view, you can see that it is behind VP and 30 mm from RPP. So we need to identify whether it is in front of RPP or behind RPP. So we need to check for the position of the view. So that is this distance is what is 30 mm from RPP. Now to analyze this problem, so always the observer is looking from the front view. The front view is always here. And since we have observed that all the planes are transparent, so naturally when you look from here, the point which is here is projected directly onto the vertical plane. So as you look from the front view, we can see the distance which is above HP. So what is the distance above HP? That distance is 45 mm above HP when you look from the front view, and that image will going to fall on the vertical plane. Since the image is on the vertical plane, which is considered as small p dash, and the distance from this the distance from the horizontal plane is 45 mm, which has been shown here. Then when you look from the top view, so as you look from the top view, the image will going to fall directly on the horizontal plane. And when you look, so the distance what you can see on the horizontal plane is the distance with respect to the vertical plane. So the distance behind VP is 60 mm. So that means when you look from the top view, we can see the distance from, this is the vertical plane what we are talking about. So from here, the distance is 60, and that distance is seen here on the horizontal plane, which is 60 mm. So when you look from the top view, the image will going to fall directly on the horizontal plane because the top view is perpendicular to the horizontal plane. So obviously that image will going to fall on HP. And since the image falls on HP, so naturally it will going to be the top view. So as yes, given in the condition it is 30 mm from RPP, whether it is in front of RPP or whether it is behind RPP, that we need to identify. So to identify that, so the condition of observer will going to come into the picture. So what is the condition of the observer? So when the observer is in the front, then the plane is between the object and the observer. I repeat, when the observer is looking from the front, or the observer is in the front view, then the image will going to be the object, the plane is between the object and the observer. That is with respect to the vertical plane. When the observer is looking from the top, then what happens? The object is between plane and the observer. So that means when you look from the top view, that is from the observer point of view, the object is between the plane and the observer. Always the condition of the front view has to be satisfied. That means always the image which you are getting in the vertical plane has to be satisfied. That means the plane should be between the object and the observer. So that condition has to be satisfied. When you look from the left side view, so here the object is between the plane and the observer. So the object is, when you look from the left side view, the object is between the plane and the observer. Similarly, when you look from the right side view, the plane is between the object and the observer. So that means the observer is looking from the right now. So when you see the observer is looking from the right, then the plane is between the object and the observer. So always it should satisfy the condition of the front view. So that means the plane should be between the object and the observer. So that condition is satisfied when you are looking from the right side view, because the plane is between the object and the observer. So obviously, so that is the right side view has to be satisfied when you are looking in the second quadrant. So when you look from the right side view, the object is behind RPP. Since the object is behind RPP, that distance is this. And when you look from the top view, you can see the behind RPP distance, which is seen in the horizontal plane. Similarly, when you look from the front view, behind RPP distance is seen in the vertical plane also. You can see that distance here. So finally, when it comes to the problem condition, the point is 45 mm above HP and 60 mm behind VP and 30 mm behind RPP. So behind RPP, it means that it is the right side view. So the left side view will not going to satisfy the condition of the front view. Obviously, that will not be considered. So this on all the corresponding images, you can see that when you look from the right side view, you are going to get the image on the right profile plane, which will be P double dash. So when you look from the right side view, the object you can see is above HP, which is that distance is here, and also the distance behind VP is also seen. So that distance will be seen here when you look from the right side view. Now this is how you can analyze in 3 dimensions. So and when I wanted to convert this into the 2 dimension, so what I must do now? I must cut it here and then rotate the horizontal plane to the top side and rotate the right profile plane to the right side. So as we do that, we will go to the step 2. So that is the intermediate rotation of the planes, which you can see here. So it is rotated, the horizontal plane is taking to the top and the right profile plane is going towards the right side. So as we seen here, so you can see the corresponding images on the horizontal plane is being rotated, and also the corresponding right profile plane is being rotated, and the vertical plane is always fixed. So you can see that here. And as you see the observer, as you observe this, see what happens. As you observe that P dash and P double dash will going to be on the same line. That means above HP is 45. That above HP, which is vertical in the vertical plane, is also becomes vertical in the right profile plane. Now initially it was the horizontal here. As we start rotating, what happens? Behind VP is getting vertical. Now as you see in the side view, in step 3, you can see that P dash will be here, which is vertical, and P is also becomes vertical, which is 60 mm. So HP and VP both are on the same plane, and it is overlapping. And then what happens? As we see here, the above HP of 45 distance, 45 mm is seen here also as 45 mm in the vertical, and here also it is vertical. But the distance behind VP, which is 60 mm here, which is vertical, has to become horizontal here. So it has to become horizontal means what I must do now. So here, as it is projected to the end of this horizontal plane, it is still being vertical. Then the distance from here to here, which is vertical, has to become horizontal distance. So by drawing a 45-degree line from this point to here, so automatically that vertical distance has been transferred to the horizontal distance. And you project this point from here to this point, you will going to get that point as P double dash, wherein you have above HP and behind VP. So you will going to get this as the right side view. So as you see the final solution, this solution and this solution is exactly the same. But here you can see the distance with respect to the profile plane, which is behind RPP, is 30 mm. So you draw the XY line and X1Y1 line. And identify the planes here. VP and HP is the one which is in bracket. Why? Because the horizontal plane is the one which has been rotated. This condition is taken care of when the two planes are overlapping each other. And in such a condition, you should always represent the rotated plane in bracket. And the vertical plane is being fixed. And the right profile plane is towards the right side. That is what we have shown here. And the distance with respect to the profile plane, that is behind RPP, which is 30 mm, is seen in both VP and HP. So from X1Y1 line, you measure the distance of 30 mm and draw a parallel entity or parallel line. Then the distance above HP is seen in VP. So since VP is above XY line, so from here you measure the distance of 45 and you mark that point, which is P dash. So what I am trying to explain here is how to draw this by using a sketchbook. Then similarly, from XY line you measure the distance of behind VP, because that distance is 60 mm, which is seen in HP. Since HP is also being on the overlapping with VP, so you will going to get this on the same line. So this becomes P. Then you draw from here. So what I must do now? From here you should have drawn a 45-degree line from this point to the XY line, because I need to convert this vertical distance of 60 mm as horizontal distance by drawing a line at 45 degrees. But when you are drawing from here to here, this will going to form a square. This will going to form a square of 60 mm. So instead of drawing this 45-degree line here, we are drawing the diagonal of the other diagonal of the square, which is 45 degrees. So from here you draw a 45-degree line and you project the P, that is the top view, onto that 45-degree line. Then what happens? This distance of 60 mm will automatically convert it into horizontal of 60 mm. And where you have the front view, on that line you will going to get the side view. So from P dash you draw a horizontal projector to the profile plane, and then from the intersection of 45-degree line to the top view projection you draw a vertical line. These two lines will going to intersect at this point. You mark this as P double dash. And then show the dimensions of 30, 45 and 60. So this will going to be the final solution. As we see that VP and HP both are above XY line, obviously this point will going to lie in the second quadrant. So the point P lies in second quadrant. Since he has given to identify the quadrant in which it lies, so we need to write the point capital P lies in second quadrant. So here he is mentioning it as point capital P because the point is in space. So always the point which is in space is always represented in capital letter, and when you identify the points, when you identify the images on the planes, then it will be on the corresponding points in the small letter. So this is how you will be able to analyze the problem. This is how we can analyze the problem in second quadrant, and also how to draw by using the sketchbook. Thank you.